Good morning, students. In today's class, let's learn about basics of capacitors and capacitance. Let's take a conductor in the form of a thin metal plate and take another thin metal plate that's also a conductor and connect one of the metal plate to a positive terminal of a battery and another end let it be connected to the negative terminal of a battery. As a result, what happens? From the first plate, the positively charged electrode takes all the electrons. When the electrons goes out of the metal get positively charged. The metal get positively charged. And so as it get positively charged, the electrons from negative terminal flows into another metal and make it negatively charged. So these two metal plates now get charged. One is positively charged, another plate is made negatively charged. Whenever the two chargers are separated, we say that a potential difference has been created. And not only that, the space between the two metal plates, there exists an electric field. Exists an electric field. An electric field is indicated by E. It's a vector. Its direction is from positive metal plate to the negative field. Hence, whenever two metal plates are connected to a positive and negatively charged terminal of a battery, so this device gets charged. This device gets charged. Let plus Q be the charge on the positively charged metal plate. And it is found that even the other plate, which is connected to a negatively charged plate, also get charged but with equal charge, equal negative charge. Hence, this is a principle. Whenever the two metal plates separated by some distance containing an insulator, say air, insulator, air, but later it is called as dielectric medium. Now, when the two metal plates separated by an air or vacuum is connected to a two terminal of a battery, okay, the charges get developed on the plates. It is found that the two plates get equal charge. It get equal charge. So one of the plate get plus Q charge, another plate get a minus Q charge. And there exists an electric field. And there exists an electric field in between. And there exists an electric field in between. Okay. Yes. And whenever the charges are separated, we say that a potential difference is created. Potential difference created between the metal plates. Let the potential difference between the two plates be V volt. So let the potential difference created between the two plates be V volt. So this is this arrangement where you can produce the charges is called as a capacitor. The capacitor now is said to be charged. The capacitor is said to be charged now. The capacitor is said to be charged by the amount Q coulombs. Hi students, I am Lakshmi Narayan. I have around 25 years of experience in teaching. Like this, you are going to get a lot of videos in my channel stressing the basic information with clear explanations. look out for the hundreds of videos. For that, please subscribe my channel and share the videos to your friends and try to get the notifications so that the preparations for your examination will be very easy with my videos. It is found that the charge that is developed on these capacitor is directly proportional to the EMF of the cell, or simply we can say that potential difference created by the cell across the capacitors. Q is found to be directly proportional to the potential difference. That means if you take the cell and keep changing the cell when increase the voltage, with increasing voltage, 1.5 volts, 3 volts, 4.5 volts, 6 volts, the charges that's developed on the this device capacitor also increases. Therefore, we can say that the charge developed on the capacitor is directly proportional to the potential difference across the capacitor, or it is nothing but approximately equal to the EMF of the cell, which is connected to the capacitor. And you know that this equation is called as a direct variation. If you want to equate it, this relation is called as the direct variation. If you want to equate it, you have to multiply by a proportionality constant. In this case, the proportionality constant taken is C. So C, here C is called as the capacitance of the capacitor. It's called as capacitance of the capacitor. Yes. So the charges developed on the capacitor is directly proportional to the EMF of the cell, or the potential difference of the cell, or the potential difference between the two metal plates. So hence Q is proportional to V. If you want to equate it, so Q is equal to CV. Where C is the constant of proportionality called as the capacitance of the capacitor. Now, can you define capacitance of a capacitor? Why not? You can define. For that, you have to solve this equation for C. Let Q by V is equal to C. So now, by using this, you can define the capacitance of the capacitor. The capacitance of a capacitor is defined as the charge developed. It is nothing but the charge developed whenever a potential difference of 1 volt is produced between the two positive, between the plates. Whenever the two plates of the capacitors is connected to a cell of 1 volt, the charge developed is called as the capacitance. What is the unit of capacitance? Capacitance is measured, capacitance is measured in farads. So farad, if you write it in words, you have to use a farad. If you write it in symbol, you have to use capital F. Farad. So farad is the unit of capacitance. Define 1 farad. Can you define 1 farad? Yes. 1 farad is the capacitance of the capacitor, which stores a 1 coulomb of charge whenever that capacitor is connected to a potential difference of 1 volt. Yes, that's the definition of 1 farad. But 1 farad is too large quantity. The commonly used capacitors have the capacitance which is smaller than the 1 farad. Therefore, The smaller value of farads are generally used in the capacitors. Are generally used. Yes. What are they? 1 microfarad. 1 microfarad. Micro stands for 10 to the power of minus 6. In numericals, whenever you get 10 to 1 microfarad, the micro is a number. It has to be substituted by 10 to the power of 6 farad. 1 millifarad. 1 millifarad. 10 to the power of minus 3 farads. The capacitance, 1 farad is too large for practical applications. Most of the practical applications involves the capacitance with smaller units, microfarad, millifarad. Sometimes 1 picofarad or 1 nanofarad, 10 to the power of minus 9 farad. Or sometimes 1 picofarad is also possible, 10 to the power of minus 12 farads. So these are the smaller values of farads. These are the smaller values of farads. Yes, this is about the capacitors and capacitance. What are capacitors? We can say that it is the devices which can store the charges. When they store the charges, they produce a potential difference of V volts. And there is a lot of practical applications of these capacitors in electronic circuits or in many appliances that we come across later. The generally used, there are different types of capacitors based on their the shapes, the material, and configurations. But most generally used capacitors are parallel plate capacitor. Parallel plate capacitor. Yes. Parallel plate capacitor. What is a parallel plate capacitor? Parallel plate capacitors have two metal plates, thin metal plates, separated by some distance by insulator. It may be air, or it may be vacuum, or it may be a rubber, or it may be a plastic, or it may be a mica sheet, whatever it is. Okay. So, yes, this is about the parallel plate capacitor. Okay, students, this is the information for this video. In the coming video, you are going to learn the derivation of, the simplified derivation of capacitance of a parallel plate capacitor. Thanks for watching.